Welcome back for example 3. Let's go ahead and look at our next cheat rule. Angle, angle, side, angle, angle, or AAS, congruence. So what this says is if two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. So here we have one angle that is congruent here. By that one arc mark. We have another angle here that has 2. Remember we talked about angle, side, angle, which needed that included side, so it would have to be there. And we don't have an included. This is a non-included side, right? It's included in this angle, but not in this one. So this is a non-included side. And the same thing is here. In this side, it's important if you see that this side is next to the one with 2 arcs. And this side is the one that's next to the one that has 2 arc marks here, okay? So it has to correspond. It has to be touching that same angle. Like it couldn't be over here touching, like this one couldn't be touching that yellow. It would have to be, the non-included side has to be touching the same angle, which is this pink one. The one with 2 arc marks. So this is angle, angle, side. And this is, well, I started here on the yellow, right? So yellow, pink, side. So angle, angle, side. And here I have to start on the yellow, okay? Angle, angle, side. And if they're both angle, angle, side, we know that the triangles are congruent. So first piece of information, second piece of information, third. 3 pieces of information for AAS, angle, angle, side. Okay. So what we're going to do is we're going to look at a proof, and we're actually going to prove why angle, angle, side is a congruence, why it is a cheat rule. And to do that, we're going to look at this. So we have given information, angle G is congruent to angle K. So I'm just going to go ahead and write that here. Angle G is congruent to angle K. We show that with an arc mark. Angle J is congruent to angle M. So these are congruent, but they're not congruent there, so I have to use 2 arc marks here. And lastly, it says HJ is congruent to LM. Right? So at this point, we know that we have angle, angle, side and angle, angle, side. So that is angle, angle, side. We know that these 2 triangles are congruent. However, we're going to prove why they are congruent. Okay? And to do that, we're going to prove that these 2 triangles are congruent a different way besides angle, angle, side, what we just learned. We're going to use our previous information, which is side, 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 angle, side, and angle, side, angle. Okay, so I think that the easiest thing to see would be we have this side, right? If we could show that this is an included side, then what we could do is we could show angle, side, angle, and angle, side, angle, right? And therefore the triangles would be congruent. Is there any way we could show, so we really just need to show that H and L are congruent. I mean, we've already shown this first angle that G and K are congruent, and we've shown this second angle are congruent. How on earth could we ever show that this third angle is congruent to each other? How could we do that? How do we show the third angle is congruent to each other if we always have this first angle and this second angle? How do we show that the third angle is congruent to each other? I hope you guys are screaming at the video screen or computer the third angles theorem, right? The third angles theorem states that this has to be congruent. Therefore, we would have angle, side, angle with that included side, angle here, right? Which would show that the 2 triangles are congruent. So let's go ahead and prove that. So what's the first thing we need? We just really need this J and M, right, being congruent. So, well, we have to show this. We have to show both of these are congruent. So let's just put the angles are congruent. So the first thing is angle G is congruent to angle K, and angle J is congruent to angle M because it's given. And then we have this other lovely piece of given information, HJ is congruent to LM. That's given. And really, that's all we need for angle side, right? That was our angle side, angle side. However, we're proving the angle side, this congruence theorem. So we have to go a step further, and we're going to say angle L is congruent to angle H by the third angles theorem. Therefore, we are going to say this is congruent. GHJ is congruent to angle KLM because of angle side angle, angle side angle. Perfect. Okay, let's go ahead and look at example 3. So in example 3, we are going to be using angle side to prove triangles are congruent. So that's an angle on the side, right? 3 pieces of information, that's what we need. We need 3 pieces. We need an angle, we need another angle, and we need a side. And remember, that side is going to be a non-included side, right? Okay, so what do we have so far? So far, we have that angle X is congruent to angle V. Okay, so you both get 1 arc mark. Then we have YZW, okay, YZW is congruent to YWZ. Okay, so these two are congruent to each other. Interesting. And then we have XY is congruent, so XY is congruent to VY here. We need to prove that triangle XYZ. Okay, so I'm gonna kind of do this. So we have to prove that this triangle here, this outside triangle, is congruent to VYW, this outside triangle here. So those are the 2 triangles that we're trying to prove are congruent. Interesting. So what do we have? I always think it's good to like kind of try to write everything we know and try to just look at it and see if we can just kind of talk ourselves through the proof before we actually start writing it all out. So what do we have? We have an angle here, we have a side here. It wants us to use angle side. So we have an angle and a side and an angle and a side. So I think we're going to need another angle. They gave us these 2 angles. I wonder why they gave us these 2 angles. Why do you think? Well, let's put a number on those. Let's say these angles were like 60 and 60. If this was 60 and 60, I also see this as a linear pair, right? So if this was 60, what would that make this? Well, that would make that 120, right? And if this was 60, what would make that? It would also make that 120. So since these are both in a linear pair and they're congruent, that also means that the linear pairs are going to be congruent and be the same thing. And there's actually a theorem for that. It's if you have 2 angles that are supplementary to the same angle or supplementary to 2 congruent angles, they are congruent, and that is the congruent supplements theorem. So we actually know that this angle here is congruent to this angle here because of the congruent supplements theorem. They're both supplementary to the same congruent angle, therefore they must be, or they're both supplementary to 2 angles that are congruent, therefore they must be congruent to each other. So what do we have? We have an angle side, and angle side, which is what we need. Perfect. Let's go ahead and write all this down now. Okay, so the first thing we have is it gives us this angle. Okay, we can write that. Angle X is congruent to angle V, and that is given. Okay, so we have one angle, right? I'm going to write that there because it's kind of the middle one. And then what do we have? Oh, we have this, which is right here, right? So we're going to say this next piece of information, YZW is congruent to YWZ. Did I say that right? YZW? Yeah, YWZ. Okay, that's given. And they're giving us this because so that we can say that these two are congruent because of the congruent supplements theorem. So that is YZX. Angle YZX is congruent to YWV because of the congruence supplements theorem. If you don't remember that, look back on your flashcards, okay? All of the stuff, all the theorems that we've learned before, they're all going to come back in these proofs, okay? So you got to make sure that you're going through those flashcards, because if you don't remember the congruent supplements theorem, it's going to be very difficult to solve this problem or other problems in your textbook. There may be another theorem, okay? So you have to be able to pull those kind of out of a hat at any time. So it helps for you to really keep going over those so that you get them in your memory so that it's easier to solve the problems. Okay, so we have that, and then our last piece is right here. You know what, though? I needed to write a few more things before this because we needed to show that these two are supplementary. So I need my friend. Where's my friend? I have a friend. Oh, you're not being my friend right now. I need a friend. Oh, here's my friend. Okay, so we're going to have to rewind a little bit. We're going to rewind here. Kind of jump the gun. Happens sometimes. Rewind. Okay, so we're just going to go all the way back here. All the way back, all the way back, all the way back to right here. Okay. Perfect. Okay, so let's just start over. We have this first piece of information. Angle X is congruent to angle V. That's given. All right, perfect. And then we have this next piece of given information that they're congruent. Now, to do that, we have to show that these are supplementary first. Actually, you know what? We can write this. That's fine. We can write YZW is congruent to YWZ. Okay, that's given. But we have to establish that these two angles are supplementary and also these two angles are supplementary. So what we have to say is that angle XZY is supplementary to YZW. So this angle is supplementary. Remember, that's kind of like they're a linear pair. They both add up to 180 degrees. That's what supplementary means. So we need to say XZY, this angle, XZY is supplementary to YZW, this angle here, angle YZW. And that is just the definition of supplementary angles. And then we just need to do the same thing on the other side. So YWV, angle YWV is supplementary to YWZ, this angle. So this angle is supplementary to that angle, YWZ. And that's just definition of a supplementary angles. They're both supplementary angles. Okay, now we've established that these are supplementary to each other, these are supplementary, and we know those two inside angles are congruent to each other. So now that we've established all that, we can say that those angles are congruent. So I kind of messed up because I didn't state that these two are supplementary, and that's kind of a big thing to the congruent supplements theorem. You have to show that those two angles are supplementary, and then you show those are congruent. Therefore, these two outside angles are congruent because of the congruent supplements theorem. So now we can say that X or YZX or XZY. What was I saying over here? XZY. Okay, so XZY, angle XZY is congruent to angle YWV because of the congruent supplements theorem. Okay, great. Now we have that. So we have our first angle. That is our second angle here. So we have both angles. We just need a side, a non-included side, right? Which is this one. It's only included by that angle. It's not included by both. Which is XY. That's that given piece of information here. XY is congruent to VY by the, that's just given. Okay, then we have that third side. I mean, not third side. We have a third piece of information, which is our side. And now we can say that those two triangles are congruent. Triangle XYZ is congruent to triangle VYW because of angle, angle, side. Angle, angle, side. Angle, angle, side. Perfect. There we go on that one. Let's go ahead and look at this next example here. Oh, yeah, let's see if you guys can figure it out. So example 3, use angle, angle, side to prove the triangles are congruent. So here's my friend the pause dragon. Remind you to pause your device. Go ahead and work it out. When you get done, press play and we'll talk about it together. All right, see you in a bit. All right, we're back. Let's see how you did. So it says given JL bisects KLM. I wonder why I would say that. And angle K and M are congruent. And then we need to prove. That's not a whole lot of information, but we only need 3 pieces for angle, angle, side, right? An angle, and a non-included side. So let's get to work. Let's talk about it before we write it down. So JL bisects. Remember, bisects means cut in half. When it cuts in half, it means we have 2 things that are congruent to each other. So JL bisects KLM, which means that this angle is congruent. Ooh, got a good 2. Is congruent to this. So we have an angle here and an angle here. Then it says that K and M are congruent. So we have 2 angles, but we need a side. Do we have a side? Oh, it's the reflexive property of congruence right there. That's going to give us our side. Then we have angle, angle, side, angle, angle, side. Boom, shakalaka. That's how you do it. So let's go for it. Let's write this given information. JL bisects angle KLM. A lot of times when you have something like this, it's like it gives you this and then you have to do the next step. So this is step 1. It's like a 2-stepper, right? This is the first step. That's the given. And then off of that, we know that angle KLJ is congruent to angle MLJ, okay? So angle KLJ, and you might have written it as JLK, right? But it's the same thing. So KLJ is congruent to angle MLJ because of the, do you know the reason? Definition of an angle, I hit that by accident, sorry about that. An angle bisector. Okay, so now we have, what do we need? We need 3 pieces of information, right? So we needed an angle, another angle, and a side. Okay, so that is our first angle right there. Okay, and then it just tells us the next piece. I love it when it does that. Angle K is congruent to angle M. Super easy. That's our second angle. And that's just given. And then our third piece of information is just side JL is congruent. I told you this theorem was going to come in handy a lot. That's the reflexive property of congruence. And we have it. We have our angle, angle, side, angle, angle, side. So we can say that those 2 triangles are congruent. JKL is congruent to triangle JML because of angle, angle, side. All right, that's it for example 3. I'll see you in a little bit for example 4.